All right, we are finally live. Hello, everyone. How are you? Cool. So
Hey,
I guess we
Pragy,
can quickly begin with our introductions. So Tarun, would you like to introduce yourself?
sure. Hello, everyone. Welcome to this live stream. My name is Tarun Malhotra. I am a lead software engineer at InterviewBit. Before InterviewBit, I was working at DirectEye, and yeah, that's about me. Hey, Pragy.
Cool. So as you can see, my name is Pragya Agrawal, and I'm also a senior software engineer over here at InterviewBit, and I'm also an instructor at Skiller. Right. So you guys have probably seen both of us in many of the previous videos at the Skiller YouTube channel. So, yes, today's topic is a very interesting topic, right? Since you all know that AI is the new thing, right? AI is the upcoming thing. So, today's topic is going to be first of all, what is AI and what will be the impact of AI on our lives? So, will AI be taking away our jobs, right? Or basically, what kind of jobs will AI take away? What kind of new jobs will AI create? And how do we prepare ourselves for the future? Okay. So yes, let's begin with Tarun. So Tarun, how would you define AI? What do you think AI is really?
Right. Okay. So first of all, guys, as Pragya said, all of us are worried about that. Hey, what kinds of jobs will AI take away? But before that, what is AI? What is artificial intelligence? So let's talk a bit about that. Basically, what we have been trying to do, we have been trying to utilize the computation power of our computers and trying to ultimately mimic. Hey, Pragya, am I audible? It seems that there is some.
Yes. So there's some lag in your audio, but yes, you are audible. Can you just okay? I think Tarun is gone. Let's just wait for Tarun to come back. In the meanwhile, let me basically introduce what AI is. So if you look at it from the perspective of the science of AI, right? Then AI, the ultimate goal of AI is to basically create something that can mimic a human mind, right? So we are trying to create an artificial brain. That is what artificial intelligence is all about. Right now, you can think of AI from a lot of different perspectives. So one of the perspectives that you can take AI from is basically AI research concerns itself with a lot of things. One of the things is what AI really is. What do we really mean by intelligence in the first place? Right? What are the capabilities of intelligence? How do we produce intelligence? Right? All these things are part of the AI research, and there are some philosophical considerations as well. So, what is consciousness? What is free will? All those different things. However, as you can understand, we are not here to talk about those philosophical parts of the AI. We are here to talk about the practical scenario. Basically, what can AI do for us? Right? What are the capabilities of AI, and how will AI change the future as we see? Okay. So, leaving aside the theoretical definition of AI, what can AI do? Right. So yes, Tarun is back. So yes, Tarun, could you tell us what AI from a practical perspective? What will AI
Yeah.
do for us?
Sure. Okay. Yeah. So basically, AI, artificial intelligence, trying, as the name suggests, that you are trying to generate intelligence which is artificial, which is not human. As of today, we historically we have been trying to look at intelligence from a human prism. That we have intelligence, we are intelligent, we can look at data, figure out patterns, take some decisions based on those patterns, and trying to figure out that hey, uh, that is what we have already always called intelligence. Now AI is that you are trying to recreate that by using the computation power of your computers and trying to figure out those patterns and predict outcomes based on that patterns, or in a way structurally trying to mimic human intelligence and making machines capable of that level of intelligence, or maybe an intelligence which is beyond our human intelligence also. So that's what AI is for me, Pragya.
Cool. Perfect. So what we can do is we can draw analogies of AI with what kind of technical revolutions we have seen in the past. So one very common thing that we have seen, one very very interesting thing that we have seen in the past is the industrial revolution that began in the 1760s and so on. Right, it lasted from 1760s to around 1800, mid of 1800s. So yes, we did see a lot of new technologies come up in the industrial revolution. So perhaps could you talk about that, Tarun?
Sure. Okay. So first of all, guys, all of you would have heard about the term industrial revolution, right? Industrial revolution essentially is the revolution which actually gave us these machines, these steamed power machines, trying to and actually ended up in automating a lot of things that were done by hand before. But I will actually give you a much more deeper perspective here, and will try to actually tie that with this new revolution that is going on, and people actually call this the fourth industrial revolution. So actually, before coming to the fourth industrial revolution, let's try to imagine the history, our past, and see how all these industrial revolutions actually change things drastically. So the first industrial revolution, as Pragya said, was in the 17th century or the 18th century, is the industrial revolution which actually gave us the steam-powered engines, and that is when all back in the day the textile manufacturing was entirely by hand, and that first industrial revolution totally replaced that hand woven clothes and gave us machines that are going to create our clothes. This had a massive impact and led to a much higher level of we actually went to a much more optimized world where things could have been done at a much larger scale, which you could not have imagined early on. Then the second industrial revolution, which is also known as the revolution, which is also known as a technological revolution, happened when the the world actually saw the invention of a telegraph. So people started building these great networks where people can talk to each other via far off to each other, and then they also started building extensively the railroad network. That is, you can very easily transport yourself from one place to another, and also via telegraph you can also communicate your ideas, that is transfer your ideas to much larger geographical regions. Now this, the second industrial revolution, also changed the way we have been living, right? It actually drastically changed things. Early on, if you can't actually move very quickly to different parts of your country, what would really happen is that there are some centers of all the innovation, some centers of all the trade, and some centers of all the education also, and everything beyond the geographical reach was a place where not a lot of things happened. But with this industrial revolution, things changed a lot in that aspect. Now the third industrial revolution, which is very closer to us, we know a lot more about that as of today. This is We actually appreciate that a lot better, is the digital revolution that happened. These computers, which actually started doing a lot of logical task for us, and started doing a lot of computation using these chips. This is the third industrial revolution. Now this fourth industrial revolution is actually the AI revolution, where not only some computations can be done using machines, but you can also hope to deduce a lot of inferences using these machines. So basically, giving machines the data and asking them to figure out more about that data, figure out patterns in that data, and then trying to also predict things. This is what the fourth industrial revolution is, and very similar in a lot of sense to the previous industrial revolutions, but also very different in some aspects. So Pragya, I would maybe if this made sense, I would want okay. Hey Pragya, are you there? Hey. So yeah, would want you to add in your two bits on how is this revolution different, let's say from the early three revolutions that I talked about, and then maybe we can also discuss about how this can also be seen very similar to the earlier revolutions.
Right, right, right. So you have already drawn the analogies with the past. So basically, the AI revolution can simply be seen as a continuation of the previous industrial revolution, right? The previous three phases. However, there are still a lot of dissimilarities. Right? So we have to understand that earlier in the industrial revolution, what was being automated was the labor-intensive part. Right? We were automating power. We were automating mechanical things. Now, what the AI revolution will allow us to do is it will allow us to automate the process of thinking itself. Okay, and thinking, if you look at it from the perspective of the things that we can do, thinking is the center of the human being. Right? So everything that we do, everything that is logical that we do, everything that is creative that we do, the science that we do, and even the very human connection that we establish with each other, right? The kind of emotional bonds we form, all that stems from our capability to think. Right? Now, because the AI revolution is going to automate this AI thinking, basically what we will be able to do is we will be able to put all these human traits of logic, science, even the human connection into a machine. Right? And maybe, perhaps we will be also able to make that machine much better, 10, 100,000 times better than the humans, right, in achieving these things. Right? So even though the AI revolution is simply a continuation of industrial revolution, this might perhaps be one of the most significant bits of the industrial revolution, because the kind of impact, the kind of lives, the changes in the society that AI revolution will be very drastic. So
Absolutely.
yes.
Pragya, I would just want to add one thing here. Of course, this revolution may actually take us to a world where the rate of change is going to be very high. We all appreciate that. But there is also, I would want to point another underlying similarity. So the rate of change today seems to be very high with this fourth industrial revolution. But if you try to imagine the kind of world that was before the earlier industrial revolutions also, you would realize that actually the world changed a lot with those revolutions also. But now, when we look in hindsight, it seems that hey, it was a small change, but that was a small change only because where we are today. But if you look at the perspective from that time of the world, then you will realize that maybe the changes then also were very huge. For example, just imagine that if there were no machines whatsoever, right? If there are no machines, the humans can actually hope to be most productive by doing laborious jobs. You actually farming yourself by hand, you producing goods yourself by hand. That seemed to be the most outcome driven work that you can do back then. But with the machines, that changed. Our perspective changed. Our what we feel is important changed, because there are a lot of things that can automatically be done. Similarly, today also, the things that are very important to us today, the jobs which gives us which are very well paid today, may change drastically in the next few years, given that our machines are getting more and more intelligent, and a lot of things that seem to be very optimized usage of our time today may not be the same as we look a few years later. So that's very important to understand.
That's right. So basically talking more about this point, you said that some jobs, I mean, most of the jobs that we thought were productive way back in the time before the industrial revolution, after the industrial revolution, we realized that those jobs are perhaps not the most productive use of our time. Right? We can invest our time much better in some other jobs. So if you look at it from today's perspective, what kind of jobs do you think the AI revolution will take up? So the title of our video is, I mean, let's come back to the main topic that we're trying to address over here. That AI is guaranteed to take away some jobs, right? That is beyond question. AI will definitely take away some jobs. What kind of jobs will AI take up first? So yes, what do you think, Tarun, about that?
Right, Pragya. So the best way to look at this would be to look at the jobs that are already being taken away by AI, right? So the first thing that I would want to talk about is the warehouse jobs. So today we have the Amazons of the world delivering millions and billions of packages all throughout the globe. You would realize that warehousing those packages and then sorting those packages to make sure that you are delivering the right package to the right place, that involved before this fourth industrial revolution, that involved a lot of labor, a lot of manual labor. Today, if you look at the warehouses of these big organizations, you would see that 90% of the job is actually automated. There are humans, but most of them are just supervising, making sure that there are not some exceptions that happens, and how do you handle those exceptions, and also then doing some interface job. That is, a lot of work is done by the AI, by the machines, and you just act as an interface and get the things done, take them to completion. So of course, warehousing jobs are being replaced as we speak with artificial intelligence. The next kind of jobs that I would want to talk about is the jobs of, let's say, customer support. You calling somebody in a call center, trying to get your job done, asking them your doubts, telling them about, hey, why is this not working? How should I get this to work? This happened to be a very big employment opportunity for us. And this was a good use of your time, because you are now assisting others to use a product that you have created. But now this is a job which is being disrupted by AI at a very big pace. You would see a lot of companies out there in the world today trying to build these chatbots, trying to automate the experience of users and automatically trying to figure out that, hey, what's the right resolution for this particular this particular use case. So all of us are using Swiggy, all of us are using Zomato. Today, if you order something on Swiggy and you realize that, hey, the order is not as per my requirement, the first thing that you do is you actually go to a chatbot. You don't actually get connected to a human immediately. You go and talk to a chatbot, and only in some exceptions you actually talk to a human, because most of your otherwise interactions can be handled by a machine itself. So yes, all the jobs, and if you try to understand the pattern behind these jobs, so I talked about two jobs right now: warehousing, I talked about, let's say, customer support. Let me also talk about one more job, because then the pattern will become much more evident. And Pragya, then maybe you can add your ideas on the same. The third job that I would want to talk about is the business of underwriting risk. So I will just talk a bit about what do I mean by underwriting risk. So whenever you buy an insurance policy, right, you go and you try to buy a life insurance policy, you try to buy a health insurance policy, the companies are trying to assess what kind of a risk profile do you belong to. And based on your risk profile, do you smoke, you don't smoke, how healthy is your liver right now, how healthy is your heart right now. Based on that, they will try to estimate how long are you going to live, and based on that, they will decide what kind of a premium they would want to charge you, so that they can balance this risk. Now, this is a job which requires you looking into lots and lots of data, trying to make sense out of the data, and trying to look at patterns in that data, and then figure out that, hey, what kind of a risk profile this particular individual belongs to. Now, this is also a job which I am pretty sure will be automated massively in the next few years. Already, we are seeing companies emerging in this space which are trying to automate all this. Now, if you look at all these three things together and try to look at an underlying story, that what kinds of jobs are these, what is the underlying pattern amongst these jobs that AI is very easily being able to automate today, you will understand that all of these jobs are essentially you trying to make sense out of a bunch of data points, right? So you have rich data available. You earlier required a human person there to figure out this particular instance belongs to which part of my data landscape, and how can I solve this issue based on how this was solved in the past, or what does the FAQ document tell me to solve this based on. Now, this is basically you looking at an instance, trying to do pattern recognition, and then trying to answer how to do it. If you look at all three jobs, warehousing, that is how do you transport a packet from here to here, what is the best route here, and how can you use machines to transport data within the same warehouse, or let's say outside the warehouse as well. And similarly, if you look at underwriting risk jobs, or you look at these customer support jobs, you will realize that you required a human to look at an instance and trying to figure out does this instance belong to, and then coming to a resolution. And now AI is very easily being able to remove these jobs and automate these jobs. So the idea being that if there are some repetitive jobs that we as a human race is doing, those jobs can be the first jobs that can be automated. Pragya, maybe what do you feel about this?
Cool, cool. So the repetition part that you spoke about in the last, that is perhaps the key point over here. So it is not about how skilled a job is. It is kind of a misconception amongst people that only the low skill jobs. I'm not really sure how do you really define a low skill job? What is a high skill job? I mean, there's no job which is unnecessary. However, people still kind of believe that low skill jobs are the first jobs that are going to be automated, which is not a job that is going to be automated, that is more likely to be automated, is a job that has a lot of repetition involved. For example, let's imagine that, I mean, let's imagine 50 years before from now, if you wanted to send a postcard, if you wanted to send a mail to someone, then there had to be a human that had to read the description, that had to read the address on the postcard, and they had to basically route it to the correct person. That, okay, this postcard must be filed in this particular cabinet because it is going in this direction. Right now, thanks to AI, this is kind of a repetitive job, right? You read something and you put it in the right place. Right? That job is very easily automatable. And if you see, almost all the postal mailings nowadays, almost all of these things are completely automated by technologies like OCR and basically handwriting recognition technologies. Right? Other than that, there are several other jobs. For example, the job of a cashier. or the job of an attendant, right? What is the major job of a cashier? Right? A person comes to you. You hear out what the problem of that person is, right? Similarly, the job of a customer support executive is the same. A person comes to you, you hear out their problem, and you direct them to the correct resolution. Now, this is a very repetitive job that can be automated. So these are the kind of jobs that will be automated. Apart from that, in the job world where people see that, okay, these kind of jobs, programming jobs, people believe are very high skill jobs. However, there is a lot of room for automation even in the programming jobs. For example, if you have seen one of the if you become a machine learning engineer, one of the first things you learn is things like what is linear regression, right? And you try to learn things like that. Okay, if I have a data set like this, then what sort of model should I choose to basically get a good result on this data set? Right? Now that seems like a very high skill job, but in fact it is not. And if you see, most of the companies like Google, like Amazon, they are working on auto machine learning techniques. Right? They are launching solutions in which you simply upload the data to their servers, and the server will the AI will choose the best model for your data. Right. So the point I want to stress over here is that is this repetition. It is the lack of creativity in a job that makes a job more or less susceptible to automation. Okay. Now there is one more thing in there which is important that we talk about. So even when we talk about artificial intelligence or lack of creative and repetitive jobs, there's a lot of spectrum in these things. Some jobs require only thinking. For example, routing a particular mail that requires only thinking, reading something and making a decision. However, there are some jobs that require a lot of hands-on activity. For example, if you consider something like a surgeon or something like a hairdresser, the hairdresser is not really doing something very intelligent, right? However, the kind of skills that a hairdresser requires, those skills need very fine motor control, right? Very good eye-hand coordination, very high dexterity, basically with respect to with respect to the hands of the hairdresser. Now, even though the AI revolution is taking at a very fast pace, the revolution that is with respect to mechatronics, right, robotics and controlling things, moving things around, right, that is still lagging behind a lot. So these things will still take. I mean, the hairdresser job will be automated eventually, but it will take much more time to automate those kind of jobs than jobs like programming. So I mean, as Andrew Ng used to say, that I know how to basically how to automate a programming job, but I don't know how to take the job of my hairdresser. So
Right.
yes,
So that's a very, very interesting point that Pragya you raised. I would actually want to go back a bit on this point and actually hammer this point across, because this should be very, very interesting to our audience. Our audience is primarily programmers, and now what they have just heard is that the probability of AI replacing the job of a hairdresser is much lower than the probability of AI replacing a job of a software developer. Now,
exactly.
this seems very interesting, and maybe also a bit depressive. Also, that maybe you should maybe become a plumber or a hairdresser today if you want to have a job in the future. But now, let's talk a bit more about that. When Pragya said that, hey, the programming jobs can be automated, of course they can be, but it's very important to understand how can you sail through this transition without you personally getting hit. Now, in a programming job, there are multiple aspects, right? The first part is that, hey, what most of us actually usually do is we build some APIs, we build some CRUD applications, right? Now, building a very simple API where you would want to pull out data from one side and then show it in a view somewhere else. So basically building these basic APIs is a job, or a part of the job that you can also imagine is very repeatable in nature, right? You just need to repeat a few steps over and over again every single time. Now, this is a job which is perfect to be automated. AI can automate this very easily. But at the same time, there are some other parts of a software engineering job that will not be that easy to be automated. For, e- for example, a software engineer also needs to architect systems, right? You need to architect system. You need to figure out that, hey, how will my system handle scale? Where do I want to introduce what kind of a layer do I want to introduce? Do I want to cache some of this? Do I want to store this in what kind of a data store format? How do I want to retrieve it? And basically trying to build the architecture of a system. this part of the job is not very repeatable. You can't just look at a system, you just can't look at system design of YouTube and say I'm just going to copy that verbatim while building a new application. You will have to make tweaks, you will have to come up with new designs with each and every problem that you are solving. This is not going to be very easily replaced by intelligence. And when I say this, please bear in mind that we are talking about the next 10, 12 years. We are not talking about the next 200 years. In the long run, all of us are dead, right? So let's not talk about what happens 200 years from now or 100 years from now, but let's talk about what happens in the near foreseeable future. Now, if you are a software developer and you want to make sure that your job is not going to be automated in the next 5 years, you should invest in upskilling yourself in the skills that are not very repeatable. So how do you design a system? And also let me talk about one more aspect here. So a lot of us are product engineers, right? So we are the owners of a product, a small product, and we also code it, we also build it up. Now building it up will require again two kinds of things. One thing which is very very repeatable, most likely that will get automated. But then there is the other part, that is what to build, how to build, why to build, maybe talking to a bunch of hundreds of your customers, trying to figure out what exactly your product can help them solve. Now this is a job which is not going to be automated by AI very soon. Of course you have a technology, but how do you leverage that technology, what do you build using that technology? There is where human ingenuity, human intelligence is required, and you should ensure that you're upskilling yourself in these skills so that you don't become irrelevant in the next few years. So that is very important.
Fair enough. Fair enough. So, I mean, I usually give this analogy in my classes a lot. There are basically two types of programmers. One of the programmer is a typist, right? Their primary job is to take some specification and to convert that into code. The second type of programmer is a thinker, right? They take a problem and they figure out how to solve the problem. Now, what you have to do is you have to become the second kind of programmer, because the first kind of programmer is going to be automated in the next 5 to 10 years. Cool.
Absolutely.
Right. Now,
And
basically,
there's where, yeah,
please,
just to add a point of Pragya, there is where upskilling becomes very very important, because if you look at the mix of software engineering jobs out there, there are millions of software engineers, right? But in reality, a lot of us are not doing the second aspect. A lot of us are just focusing on what Pragya called a typist job, that is just getting some things done, a very very repeatable process. You know how to code this up, you just create a few APIs and get done with it. This is a typist kind of a role, and a lot of us are actually in this kind of a role. We need to transition from this and move up this skill ladder, so that we are not just doing this repeatable job, but you are actually bringing something more to the table. You are not just typing a few lines of code, but you are ideating what to build, how to build, and that becomes very important. That is when you become least replaceable. And just to add one more point, guys, even if you forget about AI for a minute, if you want to become a software engineer who is very much cared for by your organization, or very much so all the companies trying to hire you, the kind of software engineers that people would want to hire are the folks who are problem solvers. You can give them an abstract problem and they can solve that problem to you. So that is what you should ensure, that you are defined by. You are a problem solver, you are not a coder. You are not here to just copy 5 lines from Stack Overflow, copy them, run them, solve a few bugs and get done with it. You essentially are a problem solver. If you make yourself a problem solver, you can be much more respected and wanted today, and also you will be at a much better place to overcome this tide of AI and artificial intelligence replacing jobs. You can still remain relevant. So that's the basic point here.
cool. So basically, diving further into this, if you look at the kind of things that a software engineer is expected to know, right? The kind of subjects that a software engineer is expected to master. So subjects like learning about frameworks, I mean, learning different tech stacks like Python and Django, or Java and Spring Boot, or React and the Merge stack and things like that. There are other things that a software engineer is required to do, things like knowing data structures and algorithms, right? Knowing about system architecture. So, Tarun, what do you think out of this spectrum of the kind of skills that a software engineer is required to do? what kind of skills are the most important? What kind of skills are the skills that people should invest learning in today, so that tomorrow their jobs are more future proof, or tomorrow their skills are more future proof?
Absolutely, absolutely. So there's a question from Suraj. He says, which new software engineering roles related to AI will be in demand in the future? So this question has two parts. Pragya, if you would want to take a stab at it, but there are two parts. Let's just acknowledge two parts here. First of all, what are the skills that we see today are very important, and what are the evolving skills that may become very important as we move along. So that is how can AI bring in a lot more skills that you should master. And at this and the other part is what are the skills that are relevant today will become a lot more relevant in the future because of the advent of AI.
Right. So basically, if you look at AI jobs are basically, you can dissect them into two major categories. Right. One of the jobs is kind of the research job, and the other job is kind of the implementation job. In the research kind of job, what you try to think is you try to research the nature of artificial intelligence itself. You research different models, that okay, if this is the kind of data, then what kind of model performs best on that data? Right, coming up with things like neural networks, coming up with things like convolutional neural networks, right, researching things like generative adversarial networks. All these things, they are part of the research of AI. On the other hand, we have the implementation aspect of AI. Like the implementation aspect of AI deals with that. Okay, I know that these models exist, but solving a real life problem is much more than simply talking about the theoretical perspective of things. Like, so I have to understand where I'm getting the data from. How do I clean that data? How do I make sure that the models that I'm applying, they actually are performing well in practice, and my customers are getting what they really want, right? So there are two parts of this AI field. Now, in both the parts, there are some jobs which can be automated, and there are some jobs which are more difficult to be automated. So if you look at it from the research perspective, there's a lot of papers that are coming out nowadays, which are not doing any innovation. They are simply saying that okay, we have this kind of problem. Nobody has applied this model on this problem, so let's apply this model on this problem. Let's see what the result is, and let's that publish that. Right? Let's just publish that. That is something that is highly automated. Right? So you can expect in the future that those kind of research activities, those kind of jobs, right, will be reduced in the near future. The new jobs that will come up in AI will be the jobs that research new models, right? Okay, what sort of new idea can I come up with that is going to help improve my model, right? So drawing analogies or drawing inspiration from the nature, just like we have convolutional neural networks, drawing inspiration from the way our basically visual cortex works, right? Jobs like this will be more in demand. Similarly, if you talk about the practical aspect of artificial intelligence, the jobs that will be in demand, the jobs that will be created in the near future, will be jobs that will be looking at, given a particular problem, what sort of model or what sort of decisions should I take? Right? The kind of problems that require you to architect the solution and not just code the solution. So you can expect that all these frameworks that you currently hear about, that okay, should I learn TensorFlow? Should I learn something like PyTorch? All those jobs are going to very quickly become irrelevant. The jobs that are going to be relevant, that are going to remain relevant, are the jobs that require you to understand the basic principles behind artificial intelligence. What is linear regression? Right? What are neural networks? How do they actually work? The theoretical aspects, the understanding, the deep understanding of those things are going to be relevant in the future jobs. So I hope that answers the question. Is there something you would like to add to this, Sarun?
No, absolutely, Pragya. But I would just want to hammer across the points again. A couple of points here which I would just want to highlight. But you covered exhaustively here, uh, guys. As Pragya said, that in research. So, for example, AI. There are two aspects to AI, right? You would want to research new models, and then you would want to implement those existing models and tweak them to solve a real life problem. In both these directions, you have some jobs which are very repeatable and can be automated very easily. For example, if you look at the folks who call themselves, let's say, data scientists, or you look at and try to figure out that, hey, if you try searching LinkedIn and try to find out for jobs that are out there in the domain of machine learning, you would see a good proportion of them actually over indexing on you knowing a particular framework. hey, can you build a model using TensorFlow for me? Can you implement this for me? Those kinds of jobs are going to be very easily replaced, very easily automated. On the other hand, the other side of implementation, where you actually figure out how to tweak this existing solution to solve for a real life problem. This is an abstract model. How do I tweak this? How do I configure this? Maybe how do I use multiple models in conjunction to solve this problem? That is where the architecting part is going to remain relevant for a long time. If you want to become a data science, if you want to become a machine learning engineer, you rather should focus on problem solving. That how do I use this to solve a problem, and not over indexing on a bunch of frameworks. That hey, I know this framework, I can code this up. I will read a research paper. I will just recreate that model here and get the, and that's all about my job. That is very easily replaced. Same at the same time, there is a wrong notion in folks that hey, the research aspect of machine learning, the research aspect of AI, you can't automate that. But as Pragya rightly pointed out, there is a good chunk of effort, of effort, that actually goes in research, where you just try to explore multiple configurations of the same model. You actually try running it through different configurations, and then publish a paper that hey, these are the results that I just got out of this configuration. Now this is a very repeatable job. If you find yourself doing the same steps again and again and hoping for a new outcome that you can publish, these kinds of jobs can very easily be replaced. On the other hand, thinking from ground up, leveraging the basic fundamental mathematical machine learning principles, and coming up with a new model altogether, coming up with a new way of looking up for patterns, that is something which requires human ingenuity. That is something which requires human intelligence, and you can't just replace that very easily. So irrespective wherever you are, in what segment, in what vertical you are currently, try to ensure that you move towards more intelligent aspects of job rather than the repeatable aspects of jobs, because knowing and being good at those repeatable stuff is only going to help you for a few years at most. It will not build a strong career for you for the next 20 years. I am very certain for that. So that is what we should all keep in mind, that hey, what are the skills that require intelligence, and what are the skills that what are the things that just require repeatability? Move towards the skills that require intelligence.
Now, basically, this question that was asked by the viewer, there's this another aspect to it. So maybe what the viewer was trying to ask is, what is the future prospect of machine learning jobs? So one thing that I would also like to point out over here is that if you look at the global supply and demand of machine learning engineers, there's a huge shortage of machine learning engineers in the world right now. Right? I mean, if you look at places like Silicon Valley, if you look at places like Bangalore, the IT hub of the world, right? If there's a huge demand of machine learning engineers, and the demand is so much that companies are struggling to meet that demand. They're struggling to hire good quality software, good quality machine learning engineers, and good quality software engineers that they actually want. So if you look at it from the perspective of the next 5 to 6 years, even though we are talking about AI automating a lot of jobs, AI taking away a lot of jobs, in the near future, in the next, 4 to 5 years, you will only see an exponential increase in the number of machine learning jobs that are available in the industry. So keep that in mind. Okay, investing in learning machine learning right now, that is still a very good endeavor. That is something that is going to secure your future, for a long time. However, while you are upskilling yourself in machine learning, just keep in mind that don't upskill yourself only in the frameworks. Upskill yourself in the problem solving part as well.
Absolutely. And if you can, as Pragya rightly mentioned, as of today, there is a lot of demand even for people who just know a few frameworks, who can code things up. But what the right way to look at it would be that hey, I can maybe use that opportunity to get a foot in the door. I can use that opportunity to get a relevant job, but then it becomes very important for you to upskill yourself in the right skills, so that your job does not become irrelevant in the next 10 years. So absolutely, it's very important to make sure that you don't get us wrong. It is not as if learning TensorFlow today is of no use. It will help you a lot. It will get you several job opportunities, because there is a big shortage. for companies trying to figure out people who know those skills. But if you use that, just use that to get a foot in the door. But then it becomes very, very important to make sure that you keep on upskilling yourself. If you feel that, hey, I got a job because I knew this framework and this is what is going to help me throughout, maybe you are mistaken. And if you are in the AI domain, maybe you know it best that, hey, that we are mistaken here. Just knowing this framework should not be enough. Similarly, I would just again talk about software engineering, because there are so many people here who are software engineers. Guys, today there is a big, big dearth of software engineering talent, right? You talk to any startup founder, the single most important resource that they will talk about is that, hey, I have capital. There is because of the Fed, US Fed, you have so much capital out there in the world. Capital is very cheap, but the thing which is most difficult to find right now is tech talent. And a lot of that aspect is just knowing coding, that, hey man, this person is good in Java, he can code, I can tell him what to build, he can just build that for me. That's great, but don't assume that that is going to stay as it is for the next 20 years. You can use that opportunity to get into the door, get into a good organization, start contributing, but make sure you don't stop there. Because if you stop there, then there is a very high probability that you will become irrelevant. But if you use that opportunity to then start tinkering with that, hey, how are products built, how is this architecture architected, maybe I should upskill myself in understanding that, hey, what's the best architecture for this problem, maybe I should contribute that, hey, you should change this caching layer, maybe you should introduce a new kind of a caching here, maybe that will help. Making sure that you move and do that transition is very important, and all of us should be cognizant of that.
True, true. And basically, there's one thing that I would like to mention over here. So you talked about upskilling, right? And this is going to be a very common thing that is going to be. I mean, upskilling is going to be the common theme of the future. So if you look at jobs today, people don't really invest a lot in upskilling themselves, in learning new technologies, in learning new skills. We're not just talking about software engineering jobs. We're talking about new skills in general. So you are going to notice that in the near future, learning new things, being able to quickly change your domain, right? Basically, quickly be able to switch from doing something to doing something else, picking up new skills very quickly. That is going to be a central theme. That is going to be a central skill that people will need to acquire in the near future. Cool. So, we have
Also,
another question from the viewer over here. Can you just take that, perhaps?
right. So Mohit will do that. But before that, in the meanwhile, Mohit, if you can take Nitin's question. But in the meanwhile, let me add one thing to what Pragya just said. Of course, the agility of learning new skills is very important. You need to upskill yourself, keep on learning new skills. Another thing that I would want to point out is being at the being at the edges of two domains. For example, that, hey, you are a great software engineer, but you also understand human psychology very well. Just an example. Similarly, let's say you are a great software engineer or you are a machine learning engineer, but you also understand finance very well. Being at the conjunction of multiple skills, this is, in my opinion, going to be a very, very highly rewarding journey to take. For example, if you are very good in one skill, do try to look at that, hey, what are the ancillary skills maybe in different industries that I can pick up, and then move to a very, very in important position where I know one domain very well, but at the same time I also know a few things about a different domain, and I can work at the very edges, the contours of those two domains, and do something great. That is going to be very, very respected and very, very required, in my opinion, guys.
True.
Okay, so now we have a question from Nitin. Pragya, if you would want to take that. What are the prerequisites in order to learn machine learning? What are the
So,
things that you should first of all focus on?
cool, cool, cool. So, machine learning, if you look at it from the academic perspective, machine learning is not a very difficult skill to pick up, right? If your aim is to go into the strict research part of machine learning, if you're saying that, okay, I want to perhaps do masters in machine learning, or I want to do PhD in machine learning, I want to basically end up in a research profile, basically in different companies, then the kind of skills you need are basically, you need very good skills at mathematics, right? What kind of mathematics subjects I'm talking about? Subjects like linear algebra, right? Subjects like statistics and probability, right? These are some things that you definitely need a lot of skill in. And I mean, a lot of people, I understand, they're kind of afraid of maths, they're kind of shy of maths. However, if you basically build these foundations in a solid manner, that will help you a lot in basically preparing for machine learning, right? Then if you don't want to take a research kind of position, if you don't want to be a very skilled in things like probability or linear algebra, then you can also look at machine learning and AI from the perspective of a framework of solutions, right? Just like Lego blocks. So basically, when you are building a structure out of Lego, right? You all have played with those Lego blocks, right? You have bricks. Those bricks have something poking out of them, and you can basically fix one block on another. So you can treat AI in a very similar manner. You can take common solutions that are applied to problems, and you can use those common solutions to tackle a bigger problem, right? You can figure out, okay, what solutions or what kind of structure, what kind of organization do I put these different solutions in to solve my bigger, larger problem. So if you look at it from the academic perspective, you can take either of those channels. You can either become very good at things like linear algebra, mathematics, statistics, and probability, and then start learning about the basics of machine learning, things like linear regression, things like what SVMs are, right? Things like what I mean, different kind of problems are, things like what probabilistic models are. Or you can take the other approach and you can start learning different ways that people are applying these different models to different problems. So,
Absolutely.
diving more into that, perhaps. So, I mean, if you're interested, if you're truly interested in learning more about machine learning, in getting the foot into machine learning, then we also have this introduction to data science course. It's a free course that will be available on YouTube, and that will be starting from next week. So, if you are interested in getting your foot into this, then I would strongly recommend that you try to do that. Right? There's nothing to lose. It's a free course, and I mean, we'll try to make sure that the skills that you learn in that course are the skills that are actually going to matter in the near future. Okay? So yes,
Absolutely. Absolutely. Uh, yeah. Just to add one thing here, guys. So as Pragya said that, hey, linear algebra, understanding probabilistical models, these concepts of maths are very very important for you to become a good machine learning engineer. And some of you, as he said, that are shying away from maths. That, hey, this is too abstract for me. I would not be able to understand this. Maybe I should not pursue that. Let me tell you one thing, guys. There is a big static friction there, that it looks very difficult at the very beginning. When, for example, if you're starting with linear algebra for the first time, you will feel that it is very difficult. It is difficult, to be honest. But then if you spend enough time, actually this is true for almost all the skills, but for linear algebra I'm speaking from experience. After a couple of weeks or a month or a two, when you start appreciating things and when you are able to identify unstated patterns, then you're able to identify and understand things at a intuitive dimension, things become very simple. So if you are scared of linear algebra today, my advice would be, please try to invest, let's say, a month at least on it. And after that, there is a big probability that you will start finding it a lot more intuitive, and you will feel that, hey, you can do that. From the outset it may look very difficult. For the first few weeks it will look difficult, but do give it a try. In my opinion, having a good grasp of these basic mathematical concepts is very very important for a machine learning engineer, irrespective of what you want to do. Of course, the degree of your understanding may vary if you want to do research, or if you just want to play and tweak these things to build a solution to it. But I would say that understanding these things, in my opinion, is very very important. So should not shy away from it. Invest time. You will be able to do a lot better with time. That's my suggestion.
in fact, I would like to say something even more stronger at this point. So, I truly believe this fact that if you are weak at mathematics or if you are scared of mathematics, it is not your fault. The fault is of your teacher, whoever taught you that particular subject. Right? If you're weak at mathematics, if you're weak at logic, then most likely you have not had good teachers in your life. Now, it's okay, right? Not everyone is fortunate to have enjoyed the support of the best teachers. I personally, I have done my education from both a third tier college in India and the best college in India. So I'm speaking from experience. I have perspective of both the sides. The difference that a good teacher can make, like a teacher that really cares about your learning, the teacher that can intuitively explain a particular topic, the difference that a teacher can make in your understanding is huge. Right? So if you are feeling shy of mathematics, what I would like to say is, don't give up just yet. just try out some other resources. Just try out some better resources. There's a lot of resources, I mean, free open resources like ocw.mit.edu, right? MIT's open course sphere, a lot of courses online that Stanford provides, and a lot of hands-on training that companies like Scalar, right, like we provide, which is coming up in the next week. So don't give up just yet. Even if you're shy, just give it another try, because we are very proud of our teaching skills, and we can assure you that once you are through our course, you will, I mean, your perspective on these things, on these difficult parts of mathematics will change completely.
Right, right. And education is one domain that may be totally revolutionized with artificial intelligence. This has access to good teachers. This is a big problem today. But maybe in the next few decades, a decade or two, you will see that maybe this will be totally revolutionized.
If
Okay,
we have any
so
more
let's
questions, let's take
yeah,
those.
yeah. Let's pick up a few more questions. There is a question from Sai Teja. He says, "Do you suggest to focus more on code optimization techniques and code design, or anything else?" Uh, okay. So Sai Teja, maybe I will talk about this for a while, and Pragya, then you can add on it. So Sai, as we said that, hey, focus on code design is one part of it, but I would say focus on architectural design. That's something which is much more vivid. That, hey, how are you going to architect systems? How are you going to solve optimization problems? Of course, very important. I would say that in general, how do you optimize something is something where beyond which a pot of gold is hidden. If you try to optimize things, that can be, you can try to optimize your code solution, you can try to optimize a problem. In general, that is something which is very important, a very good skill to have. I would say that, hey, focus on understanding that, hey, how systems are built, how systems are architected, and focus on developing the problem solving aptitude, that, hey, how can I solve a real life problem using the technology that I have. This is the skill which is most important in my opinion. When you say code design, to be honest, I totally appreciate that, hey, writing code the right way is very important. It is very important if you want to keep your code modular, if you want to keep your code extensible. The first thing which is very important of a good piece of software is how well is it written. If it is written in a, for example, I will borrow one example from Bhavin. So he happens to be the founder of Zeta. He always, if you go and look at all the talks that he gives, he always says one thing, which is that the present banks that we have, if they want to make a new product feature, if they want to start add a new product feature, they actually are going to take several years to just add a small feature. The only reason for that is the bad way they have architected their systems, or the bad coding principles that they might have used. Because now adding features on top of it is very difficult. And this inefficiency has actually created a $1 billion market for companies like Zeta, who can come in between there and try to create solutions where banks with their old technology can somehow leverage their solutions and interact with the newly changing world. So yes, code design is important, but I would still say that, hey, architecture design in my opinion is much more important than code design. Code design can be automated. You will see, as you move along, you will see that, hey, refactoring code will become more and more automated. But designing scalable systems, coming up with architectural solutions, is something which is going to be much more important and much harder to automate, in my opinion. Pragya, what do you feel about that, man?
Right, so I totally agree with that. But since Sai, I think Sai is one of our Scalar students, right? And Sai
Oh, okay.
has been, I mean, Sai has recently been through the low-level design and high-level design courses. So my low-level design and your high-level design courses. So I
Okay.
suspect that his question is a little more involved. So once again, Sai, basically, as Tarun said, most of the refactoring things can be automated. However, in refactoring as well, there's a huge perspective, there's a huge spectrum, right? So things like indentation, things like variable naming. Nowadays, if you're using a modern IDE, you almost never care about indentation, right? The IDE automatically indents the code. So those are the skills that you're not supposed to learn. The skills that you're supposed to learn in design, in even low-level design, are breaking down a problem, right? Taking a problem, collecting the requirements, figuring out how to design the solution for that problem, right? Learning the design patterns, learning the large scale architecture, or learning the different ways, looking at the different case studies of how different companies have implemented their architectures. Those are the kind of skills that you have to learn. Similarly, skills like understanding data structures and algorithms, right? Because those skills are central to your problem solving skills. Those skills are the things that are going to be important for you. Learning things like, okay, am I very good at Spring Boot? Am I very good at .NET? Am I very good at JavaScript? Those are the skills that are less relevant to you. And as time move forwards, these things, these frameworks, these technologies, they are going to be phased out eventually, right? They are going to become irrelevant. The problem solving is going to remain forever, basically.
Absolutely, absolutely. Okay, so there is a question from Gaurav, and that happens to be a very, very interesting question. He says that he has read some articles which says that AI can be very dangerous as well. How companies are taking care of bad aspects of AI so that this awesome evolutionary change due to AI does not end up misusing the technology. So yeah, that's a very, very interesting point. Pragya, would you want to take lead on that?
Yes, yes, definitely. So, first of all, what I would like to say is that yes, the picture is not all rosy, right? We are not here to paint the utopia over here. AI, like with any technology, AI gives us a lot of benefits, but it also comes with very significant risks. And since AI has the potential of being one of the most powerful technologies, the risks are also very significant. Okay, so let's go back to the invention of AI, right? So perhaps the first artificial intelligence system that was theorized was by Claude Shannon, right? So I'm sure that all of you have heard of that person, the father of information technology. In his bachelor's thesis, he gave information technology, but very few people know that in his master's thesis, he created something called the Shannon's mouse, and that was the first artificially intelligent device, basically, right? And he used to believe that in the near future, basically 100 years or 200 years from now, what we will have robots take over the entire world, right? And basically, Shannon had that opinion. Now, I'm not saying that that is going to happen, but a lot of very powerful, a lot of very knowledgeable people also share that opinion. So, if you take example of Stephen Hawking, people like Elon Musk, people like Bill Gates have warned us about the very real risk of AI taking over the world. Right now, there's a way to handle this. It's not like there's nothing that we can do about this. This, like most problems, is definitely a solvable problem. However, if you expect just large companies to solve this problem, that is not going to happen. The solution has to come from you, right? So what I would basically stress over here is that since you are the engineer, since you are the future of the world, it is your responsibility to take these things as a challenge, to upskill yourself in these fields, and to make sure that the AI in the future is safe AI, right? So there's a lot of research that can be done about things like what safe AI is. There's a lot of research that can be done about basically making sure that the AI is not trained on biased data, right? So you might have heard cases in which Facebook's AI, right, that started tagging black people as animals, right, as orangutans, because it was trained only on the images of white people, right? So it is your responsibility as a machine learning engineer to take care of these things, to understand and come up with solutions for these things, right? Apart from that, there is also a lot of research that can be done in how to best apply AI in the large scale society. So as we understand that, if you look at any particular technology, whenever a new technology comes into the picture, it only increases the distance between the poor and the rich, right? So this income gap, this disparity between the powerful and the less powerful, this only increases because of a new technology, and that is a very real concern with AI as well, right? So if you look at billionaires, if you look at large scale companies that are using AI to basically remove out any competition, right, there's also a very real risk of AI being weaponized. So if you see nowadays, there's companies like Boston Dynamics, there's several other companies that are basically trying to automate killing machines, right? So that is a very very real risk of AI, and the only way forward, the only way we can tackle those things is first of all to educate ourselves, right? To upskill ourselves in this field, and secondly to be more vocal, right? To actually bring ourselves into these fields and basically shape the future ourselves. So yes,
Right.
that is kind of what I think. Yes.
Right, Pragya, I would just want to add a couple of more points here, which I feel are very, very, which are very, very near term. Matlab, we can actually see those things happening in a very short duration of time, and maybe we are already seeing those things happening. And this is a very, very interesting conversation. So I will maybe just take 5 minutes to discuss a few things here. So first of all, guys, the point that Pragya said that hey, with new technologies, one unintended consequence of a new technology may be that your bar to entry increases a lot. Let's talk about that a bit. For example, if you want to come up with a new Google Maps today, will you be able to do that easily? The answer is no. It's very, very difficult. The point is that the amount of data that Google has accumulated, it has set a very, very high bar of entry for new solutions to emerge or new competition to emerge. And to be honest, from a very structural point of view, any any domain where there is no competition, we are headed in the wrong direction. Similarly, let's talk more about that. For example, Amazon today has so much information about what are the things that we really would want to buy, what are the things that the market wants. Now, if I come up with a new product today, which is very, very interesting, I would want to use Amazon's distribution to be able to reach out to the masses. Now, Amazon can very easily, and it is what it's actually doing, unfortunately, it is very easy for them to copy my idea to create a clone product and to use their distribution to now actually sell that at a much cheaper price now and just gobble me up so that there is no competition. For example, the companies like Swiggy, Zomato, they are valued so much. We have a Zomato IPO coming up in the next few months. Now, Zomato is not only valued because the deliveries that they are making, or but a very, very important part there is that the data that they have aggregated. Zomato would know that hey, if I want to sell kadhi chawal in Delhi, what's the best price to sell kadhi chawal in Delhi for? What is the best time where people are actually what is the time where people are actually going to order a lot of kadhi chawals? What happens in different seasons? What happens in different parts of the city? What's happened in different times of the day? Now that data is invaluable, right? And this actually increases the bar to entry. For example, tomorrow if I want to open my own restaurant, or if I don't want to open my restaurant, I already have a restaurant. Now it becomes very difficult for me to compete with a company like Zomato or Swiggy because they can actually use that data, leverage that, and come up with a new cloud kitchen tomorrow, which will perform much better than me because they have access to a lot more data. Now, what I'm trying to say here is that a very real risk is that the barrier to entry may increase significantly. The companies that are already powerful may become significantly more powerful, and the others may actually be left out of the they do not have the possibility of competing and coming up with ingenious ideas. That is one thing that I fear the most about. And this is not only for AI, this is actually for any new technology that comes up. But this is one thing that I really fear about. Another thing that I would also want to talk about is the information warfare that is happening. So now, guys, if you appreciate, all of us have our own social media presence, right? And the main source of our news happens to be social media today. I hope everybody agrees to that. Nobody now, very few of us actually read newspapers today. Our news actually comes from our social media. Now, try to understand that what we are essentially doing, we are exposing ourselves to the possibility of an information warfare. Now, if in my echo chamber of my social media, I only see the news that somebody else wants me to see, do you understand that you can actually change the way a society thinks? You can change the way a group of people think and maybe hide the things that would have mattered to them and only show them the things that you would want to show them. So this information warfare, you would have heard about companies like Cambridge Analytica. So this is a company which actually helped different political parties throughout the world trying to tailor make their reach, their outreach to potential voters. Now this, what they do is they would want to hide all the negative things about a particular candidate that you would not want to show to a particular set of people, and only amplify the messages that are very heartening for that group of people to see. So what you can essentially do is So essentially, that's just one more minute I will take, and then we can move to the next question here. So if you think about politics, in all honesty, politics or governance is a monkey balancing activity. There is no easy way out. You can't come up with a new scheme which is going to make every single person happy. Now, if you come up with a new bill, you come up with a new law, there is bound to be one segment of people who will be happy about it, and there is bound to be another segment of people who will not be happy about it. Politics is all about monkey balancing. Now, if you leverage this information warfare, what you can do is everybody will have you can put anybody on a spectrum and say that, hey, these are the things that I like about him, these are the things that I don't like about him. Now, what with information warfare you can do, you can only expose the things that somebody would like about you and just make them totally not they would not even know about the possible downsides that you actually come up with. So this is very interesting and a very important field. The first thing that we should do is to make ourselves cognizant. That is, before making our very strong beliefs about something just because of a few articles that we read online, first thing that we need to do to fight this is to be cognizant of the fact that, hey, maybe our source of information is biased, maybe we don't have the full picture in front of us. So it's very important for us to first of all absorb everything and only then try to make opinions. So this is the first thing that we should do: be cognizant of the possible effects that technology can bring uh, bring with itself. Yeah. Okay. So not very sure if that was very boring to a lot of you, but I just wanted to share that because that is very important for us to be cognizant of. Okay. So now there is a question from Suraj. He says difference between a machine learning engineer and a data scientist. How do these two roles differ from each other?
Right. So, I mean, there's not a lot of difference between these two roles. And in fact, if you look at most companies, they don't really care about the title, right? They don't really care about the title either. So, from the, I mean, there's a lot of gray area in these things, and there's not a clear delineation. However, traditionally, if you look at the data science role is more about looking at data and simply making inferences manually from the data. So, for example, imagine that you are part of a fintech company, right? You're dealing with a company like DE Shaw, and what DE Shaw does is basically it takes investments from different investors, from large scale investors, and DE Shaw figures out that, okay, what are the best companies to invest into, right? Best equity companies, best different types of stocks to invest into to give the best return to the investors. Now, if you're an analyst, if you're a data analyst with DE Shaw, your job is mostly looking at a lot of data about these companies, looking at the past performances of these companies, and coming up with predictions that, okay, this is how the company is going to perform, right? That is the job of a data scientist, looking at data yourself and coming up with inferences. The job of a machine learning engineer is primarily to take this and automate this completely. Okay, the job of a machine learning engineer is not to say that, okay, given this data, what are the inferences I can make. The job of the machine learning engineer is to say that, okay, given this data, what algorithm can I apply on it, right? So that the algorithm does the job of the data scientist for me. Okay. Now, as you can imagine, both these jobs have a lot of overlap between them. Right? If you are a good data scientist, it is very likely that you are also a good machine learning engineer. Similarly, if you're a good machine learning engineer, it is very likely that you are good at making those data inferences yourself. Right? So there's a lot of overlap, and mostly the companies don't really care about whether you are diving into a data science profile or whether you are diving into a machine learning profile. So what you should focus on is learning the basics of machine learning and data science. You should learn the basics of probability, the basics of this machine learning theory. You should not really focus on what the exact job title is, because those job titles are very meaningless and they are very flexible in the current world. Cool. So yeah.
Yeah, just one thing there, Pragya. Of course, there is a lot of overlap between these two job titles. But one thing that I've noticed after looking at multiple job openings and multiple job offerings, I have noticed that companies usually give the title machine learning engineer to folks who are much more heavier on implementation. They would be much more, their job role will involve a lot more implementation, versus people who actually call themselves data scientists are usually folks who would want to just build models and then give those models to somebody else to actually implement. But as Pragya said, if you want to become a good machine learning engineer or a good data scientist, then you will notice that there is a lot of overlap, a lot of skill overlap between the roles. But one thing that I would just want you guys to be wary of, that I have seen a lot of machine learning engineers who do not necessarily have a very good grasp over the fundamentals of machine learning. That is something that you should personally avoid. If you want yourself to call a machine learning engineer, that's great, but make sure that you're not somebody who does not have a very strong grasp over the basics, the basic understanding of data science, the basic understanding of machine learning models. This is something which is necessary if you want to have a good career ahead of yourself. That's it. Okay, so there is a question from Shreyas. He says, is there a demand for people who have both the skills? They have data science skills and they are also good software developers. The short answer is, of course, yes. Uh, there are lots and lots of companies who would love to hire people who are good software engineers. At the same time, they have a good understanding of data science as well. So if you are somebody who has both these boxes checked, I can assure you, you are going to be in great demand. That is a very you should actually, if you are a software developer and you are figuring that, hey, maybe what's the next one skill that I should add to my understanding that will maybe help me grow a lot, you can think about data science machine learning. If you understand the principles of data science machine learning, maybe you will get a lot more doors will open up for you. Similarly, if you are somebody who is very good at theoretical data science, you know how machine learning works, you know how different models work, and you are good at understanding models, trying to figure out that, hey, what model to apply in what problem. If you also pick up the skills of implementation, if you also pick up the skills that are important for a software developer, that is, you pick up the skills of architecting systems, then you can increase your value by a lot. You can also increase the kind of impact that you can make by a lot. So that's my short answer. Yes, there is a big demand for people who have both these skills.
Right, right. And in general, Tarun, I think, pointed this out earlier in the conversation as well. The most important and the most impactful jobs that are there in the world are the jobs that are interdisciplinary, right? The jobs that are at the edge of two different skills, right? So it is always a good idea to be a kind of a T-shaped person, right? You should have a broad perspective. You should try to make sure that even though you have mastery on one skill, you should try to expand your horizon, because the true innovation that happens at those boundaries. True innovation happens when you mix two ideas and you come up with a new idea, right? So yeah, that is basically it.
Hey Avik, hi. It's so nice to see you also again after some time. Will ML be the road ahead in tech? Okay, so will machine learning be the road ahead in tech? Maybe. So just to summarize what we have been talking all about, that yes, in my opinion, machine learning or data science or artificial intelligence will become the dominant player or the dominant theme in the next industrial revolution, the industrial revolution 4.0 that we talked about. So yes, it is going to be a very dominant theme, in my opinion. You are going to see lots and lots of new companies and ideas mushrooming, where you are going to leverage data science and build a lot more impactful products. So you think about anything in general. For example, if you pick up any domain whatsoever, pick up, for example, education. Now you will have a lot of great companies emerging in the domain of edtech, but you can see that in the future, machine data science, artificial intelligence is going to be a big part of the story in education also. You pick up any other domain. For example, you think about getting people to move from one place to another, right? So we already have airplanes which are almost automated. The pilots come into play only for very short durations of time, and also for very some of the exceptions that actually can arise. But a lot of flying the airplanes is totally automated. Similarly, you are going to see in the future that, hey, a lot of trucking industry, actually interstate traveling over highways, where you have a truck trying to move some goods from one part of the country to another part of the country, you are going to see that this will become automated in no time. There are some very interesting organizations, some very interesting companies that are trying to automate a big portion of the trucking industry. Of course, there will be a truck driver, but that person will just be there to handle exceptions, and majority of the boring truck driving on highways at the constant speed will be automated. Similarly, if you look at, let's say, driving of self-driving cars is going to be a reality in our cities also, maybe in the next 15, 20 years. So yes, machine learning, data science is going to play a big role there as well. To talk about Uber, you talk about Ola. These are big organizations today, right? And these are you see that, hey, they have utilized tech in a very ingenious way and solved a real life problem. But now, what is the major problem that Uber faces today? The major problem that Uber faces today is the driver side of things. If they want to maximize their profits, the first thing that they would want to get away with is drivers, unfortunately. That is what this decides in different geographies, different kinds of profits that a company like Uber can make. So now, if you have a scenario where you can use machine learning, you can use data science to actually automate this intra-city driving as well, then these companies can actually become much bigger, and you can have a scenario where tech and data science being a very important part there can actually revolutionize industries altogether. Similarly, let's talk about just one last example, and then I will hand over to Pragy to add his ideas. If, for example, your driving becomes automated, you have the, artificial intelligence driving your cars. Now, it's very important for us to understand that this will have a big implication on, for example, the insurance industry. Now, if there are no humans driving cars, the probability of you requiring car insurance, most of the accidents actually happen because of human error. If humans are thrown out of the picture, now the probability of you getting into accidents is very less. Why are you going to pay hefty premiums on your cars to insurance companies and just to keep your car insured? If the probability of accidents reduce, then this entire industry ceases to exist. Similarly, you can imagine that yes, the next wave of revolution will have data science, artificial intelligence at its very heart, and you are going to see lots and lots of ramifications, and we as humanity moving to a much more optimized version of ourselves. Yeah, that's what I feel. So yes, Avik, if you want to learn machine learning, go ahead, do that. Right time to learn this new skill. You are going to notice that, hey, it has helped you a lot in your longer career.
Cool. So one thing that I would like to point about here is that machine learning is like a spice, right? With any technology, it spices things up. It adds on new capabilities to what you can already do. So it is not going to be the case that machine learning is going to be everything in the world, right? It is going to be at the center of everything, but it is not going to be everything. What you have to understand is that the future is going to be, I mean, everything in the world is going to involve a bit of machine learning. However, the domains are still going to remain valid, right? So what you should focus on is learning how to apply these skills of machine learning, right? This technology of machine learning in different domains, and that is true with any emerging technology, be it machine learning, be it something like blockchain, be it something like quantum computing. What you have to understand is how these technologies work, and you have to get that understanding so that you can know how to apply these technologies in different problem domains. Okay, so the point over here is that machine learning is a theme. It is going to spice up everything. It is not the entirety of the world. Okay, cool. So yes, let's take the next question, Tarun.
Right. So, do we need a good infrastructure to study machine learning? By infrastructure, I mean hardware resources. A very important question by Nathan. Pragya, he's basically asking that, hey, what are the bare minimum hardware requirements that are required for me to do something meaningful in machine learning?
That's a great question. Now, if you look at most of the sciences, if you look at something like physics, right, there's an amount of physics that you can do studying. I mean, there's an amount of physics that you can learn via the books or via videos, right? So anything up till class 12th level, you can fairly do. However, as you move higher, you have this requirement of really amazing machines, right? You require laboratory equipment. You require large scale machines, be those particle accelerators, be those CNC machines, be those a lot of different things. You require a lot of expensive equipment to grow further, right? Now, traditionally, computer science has luckily been, has avoided this problem, because all you need to be a good computer scientist is bare minimum laptop, and you just need your brain to think about things and basically come up with new solutions. Okay. However, with the advent of machine learning, especially with the advent of big data, this scenario is changing. For example, if you consider something like OpenAI's GPT-3, right? It is estimated that training that GPT-3, right, coming up with the architecture is different, but just training that GPT-3 on the data required a person to invest $16 million. So if you don't have $16 million, there is no way you can train GPT-3, right? So that is true. That is true that because of AI and because of machine learning, you cannot train large models unless you have access to those expensive resources. However, that is only a very small part of machine learning. Okay, if you still want to do very core research, right? If you still want to contribute meaningfully to the domain of machine learning, it is still possible to do that, and I mean, it will remain possible to do that for the next, I mean, 10 to 20 years. You can still meaningfully contribute to machine learning without having fancy equipment. Okay, so don't try to think that okay, if I want to become a machine learning engineer, that I definitely have to have a RTX 3070, I have to have a top of the line CPU, I have to have a top of the line machine. That is not true. In fact, with companies like Google, right, I'm sure you have heard of tools like Google Colab, right? So a lot of these companies, what they're doing is they're providing free resources for students, for researchers, for startups, free resources in the cloud. So you don't have to have a powerful machine on your system. You can have a very basic laptop. You can connect to Google Colab, and Google Colab will provide you the necessary GPUs, the necessary computation power that you need to basically grow in this field and to do important research in this field. Yes.
Absolutely, guys. So if you want to start, Google Colab is the answer. That how do you start, right? So if you want to train any of your models, go ahead and use Google Colab. Pragya, if I'm not wrong, for normal accounts, you get what kinds of configurations do you get in a normal Google Colab account?
I'm not well aware of that either. But I mean,
Okay.
you will not you will not run out of resources anytime soon, right? You can learn most of the machine learning, almost all of the machine learning. You can learn on your systems. You require fancy equipment only when you are dealing with industrial level problems. Only when you're saying that okay, I have data of millions or billions of users. Now I have to train a model on that. That is the only case when you actually require those large machines, those large clusters. For learning machine learning, you can simply have a basic laptop and use Google Colab completely, right? That is going to be more than enough for you.
Okay, guys. So it's 6:30. We will just pick up one more question now, and then we'll end the session. Let's look at the last question. Do we have any more questions? Okay. There's a question from Hari. He says, "What are the chances of a bot gonna have emotions and become biased?" Okay, so what is the probability of your AI become biased? We have talked a bit about that already, but yeah. Hey, Pragya, would you want to add on to that?
Yes. So, I mean, there's a lot of debate around this area. Frankly, from my perspective, I am a firm believer in the fact that everything that humans do, it can be automated, right? So you can totally have a bot which shows emotions. Now, I'm not talking about the big picture. I'm not talking about the philosophical things over here. I'm not talking about whether the bot will have free will or whether the bot will actually be conscious. I don't care about any of those things. What I am saying that the bot will at least be able to mimic human emotions, right? That is a very real possibility, and that is going to come soon enough, right? 20 years down the line, that is going to be a reality. Okay. Now, what are you going to do with this bot? Are you going to take a bot like that, and are you going to put that bot in charge of important decisions, right? That is not likely a scenario, right? Why would you do that? We already have seen that humans make a lot of errors, so it is not a very big it is not a very I mean, it is not a very likely scenario that we will have an emotional bot be in charge of important decisions, right? Be in charge of important governance or political decisions. So, I mean, once again, taking your question, having a bot that has emotions is a very real situation, but that is not going to be a big problem for us because you won't have that bot in important decision making places. Okay.
Right. So of course, your artificial intelligence can become biased because just by the kind of model you build, your models can always be biased. Pragya gave an example where some machine learning model of Facebook was not identifying people of one particular color as people, which is of course your systems can be biased because of the kind of data you feed that to. Emotions, as Pragya rightly pointed out, you can mimic emotions, but to be honest, I personally am not very worried about AI actually being consciousness of its own. It's a very big topic. There are very strong arguments on both sides, but let's not go there, discuss that right now. But yeah, I would say that hey, of course your systems can be biased. You can also mimic emotions to some extent, but that's not the most worrisome aspect here. But yes, how to make sure that your systems are not biased, that is important, and we should be cognizant of that, and we should take efforts to ensure that the systems do not get biased, because it's very easy, right? So you can always have a sampling bias, and your the patterns that you show can always be biased, and your machine as a result will always end up being biased. But
And,
yeah,
and basically the only way of making sure that that does not happen is to take action, right? Don't let your future be dependent on what other people do. Upskill yourself in these areas, right? Be vocal about these things, learn these things, and take action yourself. Shape your own future. That is kind of the summary of this talk, basically.
make sense. Make sure that you have a seat on the table, and to get the seat on the table, make sure that you are upskilled enough. So yeah, that's a very nice way to summarize this session, that yes, it's important to maybe try to upskill yourself in these domains, and then so that you can also have a say in what happens with your future. Just one reminder, guys, we are starting with a course on machine learning and data science at Scalar Academy YouTube channel from next week. If you are interested, feel free to join us in that course. It's going to be a totally free course where we are going to take you through the basics and help you become better at machine learning data science. And if you have any questions, feel free to write to us. You can also connect to us on LinkedIn. My name is Tarun Malhotra. Pragy was there with me. Thanks a lot, everybody, for joining in. Hope to see you guys again pretty soon. Bye bye.
Have a nice day, guys. Bye bye.